Hello everyone, welcome to Academic Coordinates. So we've looked at arithmetic sequences, which are also linear sequences. We've looked at quadratic sequences. We've looked at geometric sequences. Now in this video, we're going to look at series. In series, we are basically considering the sum of any sequence of numbers, right? For example, if we had 2, 4, 6, 8, right? So we see that this is a sequence. It's actually an arithmetic sequence. You know what I'm saying? The terms increase by the value of 2. So we add 2 from the previous one to get the next one. But when we speak of series now, we speak of a situation where we sum everything up. 2 plus 4 plus 6 plus 8, right? So this is series where we sum stuff up. So we've got what we call finite series, right? So a finite series, we are basically summing, or it's a sum of finite terms, right? So it's a sum of terms that are finite, terms. In other words, we don't have a situation whereby the terms are just continuing to infinity, right? And then we use Sn for the sum of the first n terms, you know? So, for example, what Sn represents, it represents that from the first term T1 plus T2 plus T3 plus whatever until the nth term. So this is the sum of the first n terms. So for example, like we have the, if we are given an arithmetic series here, we've got 2 plus 4 plus 6 plus 8, right? So the sum of the first, how many terms? 1, 2, 3, 4. Or maybe let me just put plus 10 here, right? So let's say, for example, we are interested in the sum of the first 4 terms. That is going to be S4, right? So that's going to be 2 plus 4 plus 6 plus 8, right? So what is that? 2 plus 4 is like 6. 6 plus 6 is 12. 12 plus 8 is 20, right? So the sum of the first 4 terms is 20. You guys get that? And then we also have what we call an infinite series, right? So as far as infinite series is concerned, we speak about the sum of infinitely many terms, like in a sequence, you know. So we've got a situation of 2 plus 4 plus 6 plus 8, and then our series continues. So it is a series of infinite terms. So we do not we are actually summing without bound, you know. So it's basically represented as S, then with an infinity there, right? So this is going to be T1 plus T2 plus T3 plus T4, whatever, plus, you know, we are continuing, right? We are not bounded. And now there is a notation, guys, that we use that is very much useful whenever we are speaking of summing stuff, and that is called the sigma notation. That is the sigma notation. Someone once said the stigma notation. It's not the stigma notation, it's the sigma notation, right? And then this notation is actually used for writing the sum of the given number of terms, right, in a sequence, and it's represented like this. You know what I'm saying? That is the sigma notation. So it is the sum expression, All right, so basically that is the sigma notation. For example, here we can have the nth term, or Tn, for example, and then we are going to start from a specific n. Let's say n is equals to 1, and then we're going to end, let's say, at 4. So what does this mean? This means that we're going to have 3 times 1. We are starting from n is equals to 1, plus 3 times 2, plus 3 times 3, plus 3 times 4. You see, we end at 4. And I want you to take note that this increases by 1, right? So let's actually do that. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. You know what I'm saying? So if you guys, just count this, 3 plus 6, that is 9. 9 plus 9 is 18. 18 plus 12, that is going to equals to 30. So now let's basically express the sigma notation and just appreciate its different elements right here. So the sigma notation is basically this zig, zig, zig thing here. And then here we have got the general term, or we've got the nth term, right? And then we are starting from a specific, n. Let's say n is equals to, I don't know, m until, let's say, p, So now, what does this mean? So m is the starting index. The starting index. That is where we start, So what do we have? This expression is going to be Tm. So we are starting from m. We are going to substitute m. You know what I'm saying? And then now p is going to be the what? The end index, right? The end index. So, and one important thing that I want you guys to take note here is that this m is going to be increasing, right? It's going to be going up it's going to be increasing from m until p by steps of 1. So what I mean by that is that the second term here is going to be t of m plus 1 plus t of m plus 2. You see, it increases by steps of 1. Then we're going to continue until t of what? T of p, And also, this tn, what does that stand for? That is the term of the sequence, You know what I'm saying? Okay. And then now, the number of terms that you're going to have here, there's actually a simple formula that is actually there. So now the number of terms, maybe if you can be asked that question, in this series will equals to the end index, in other words, in our case, p, right, minus the start index. What happened to my English? The start index plus 1. So the start index was what? It's m. P minus m plus 1. This is going to give you the number of terms right here, Okay, guys, so basically that is sigma, explained in just simple terms. So let's just do some examples here to just appreciate this thing. So if we are told to expand, this sigma right here, this is 3 to the n, right? From n is equals to 1 until 4, So this is going to equal to what? 3 to the 1 plus 3 to the 2. Remember, it increases by 1 plus 3 to the 3 plus 3 to the 4, you know. So what is this? This is 3. 3 squared is what? 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. Obviously, you guys might have calculators when you are doing these things. And then, if you can take note, this is the sum of the first 4 terms. You know what I'm saying? So let me actually calculate that. I'm not even embarrassed to use my calculator right now. Yeah, I don't care anymore. So this is 120. So you can also check at home and see if you get 120, so that you all can know if I'm able to use my calculator. Okay, cool guys, let's continue. So now let's do another question. So here we are told to find the value of the series. We are told to find the value of the series. So basically, it's the sigma. Then you've got 2an from n is equals to 3 until 5. You know what I'm saying? So basically, let's first expand this. And obviously, if you guys take note that we've got an unknown term here, I mean an unknown which is a, you know, so our value is going to be in terms of a. So don't feel weird when you're doing stuff like that, you know. So we are starting from n is equals to 3. This is 2 times a times 3 plus 2 times a times 4. You see, it increases by 1 plus 2 times a times 5, you know. So 2 times a times 3, that is 6a, plus 2 times a times 4, that is 8a, plus 2 times a times 5, that is 10a, you know. So 10a plus 8a, that is 18a, plus 6a, I believe that is 24a. This is the value of the series. You know what I'm saying? Okay, let's continue. All right, fine. So now, if you are asked how many terms are in the series, how many terms are in the series? Okay, and then you are given this expression here, age right here, you know, and then a is equals to 2 to 8. Okay, so how many terms are in the series? So basically, without even expanding here, you look at the end index minus the start index plus 1. That is going to give you the number of terms in the series. So the end index is 8 minus 2 plus 1, right? So BODMAS, right? Okay, so let's add here minus 2 plus 1. What is that? Minus 2 plus 1 is minus 1. So 8 minus 1, that is 7. So there are 7 terms, right? Okay, cool. So let's just prove that. You know what I'm saying? Let's just prove that there are indeed 7 terms. So we are starting from a, and then, okay, just a second. So a is going to be 2 times h plus 3 times h plus 4 times h plus 5 times h plus 6 times h plus 7 times h plus 8 times h. So this is 1, 2, 3, 4, 5, 6, 7. Do you see that we are correct? Okay. Okay, guys, let's continue. So now let us expand this. So we're given this sigma. We've got 7 to the n right here. From n is equals to what? Is equals to 5 to 10. So let's expand this. So we've got 7. We are starting from 5 plus 7 to the 6th plus 7 to the 7th plus 7 to the 8th plus 7 to the 9th plus 7 to the 10th, you know. So now we have expanded this, you know. I don't know what the answer is. You can calculate it at home. Yeah. Okay, guys, let's continue. So that is just the expanding part. Okay. So I trust that you guys really appreciate this and it makes sense. I think maybe let me do 2 more questions and then just end this with a nice summation, right? So if you are told to calculate the value of A, right? If you are told to calculate the value of A, in this case, and then you are given this, this is A times minus 3 to the m, from m is equals to 3 till 6. This now equals to 2,700. So you need to expand this first of all, right? So it's going to be, the first term is going to be A times minus 3 to the 3 plus A times minus 3 to the 4th plus A times minus 3 to the 5th plus A times minus 3 to the 6th, right? So this should equals to what? This should equals to 2,700, you know? So we're going to factor out A into minus 3 to the 3 plus minus 3 to the 4th plus minus 3 to the 5th. Wow, that looks like a weird 5. Plus minus 3 to the 6th. Okay, 1, 2, 3, 4. So 6 minus 3 plus 1. Okay, great. This should equals to 2,700. So let's actually do that calculation. Minus 3 to the 3. Okay, so minus 3 to the 3, that's minus 27. Then minus 3 to the 4th. Minus 3 to the 4th, that is 81 plus 81 plus minus 3 to the 5 to the 5th. That is minus 243 plus minus 3 to the 6th. That is 729. So we add everything up. Is equals to 2,700. Okay. So that is 729. Let's say plus 81 minus 27. Okay. Minus 243. That equals to 540. 540 times A is equals to 2,700. So your A now is 2,700 divided by 540, right? So 2,700 divided by 540, such that your A equals to 5. So do you guys see how we utilize these things to actually solve our problems, you know? Okay, All right, guys, I think let me just end this by just exposing you guys to the rules of sigma notation, and then the rest of the stuff that are here are going to be done by my mentees. Okay, so basically the rules for sigma notation, the first one, if you're summing AI plus BI from I is equals to 1 to N, so you can separate this thing in this fashion. I is equals to 1 to N plus sum of BI from I equals to 1 till N. So that works. Then the second one, if you've got a constant times I right here, from I is equals to 1 till N, you can take out the constant times AI from I equals to 1 to N. So that works. Then number 3 here. Okay, number 3 and number 4 is going to be very important. Let's say, for example, you've got AI plus 1 from I is equals to 1 to N, right? I want you guys to take note that this is not equals to AI plus 1 from I is equals to 1 to N. Let me just prove what I'm talking about here. If you've got, for example, 2N plus 1 from N is equals to 1 to 3, this is 2 times 1 plus 1 plus 2 times 1, 2 times 2 plus 1 plus 2 times 3 plus 1. Okay, I'm supposed to use square brackets here, but anyway, 2 times 1 plus 1, that is 3. 2 times 2 plus 1, that is 5. 2 times 3 plus 1, that is 7. So the final answer here is 15, right? So now if you've got 2n plus 1 from n is equals to 1 to 3, what this means simply means that you've got 2 times 1 plus 2 times 2 plus 2 times 3, right? You sort of do that, then on everything now you add a 1. So 2 times 1 is 2 plus 4 plus 6 plus 1. So this is going to be 12 plus 1, which is 13. So it actually proves that be careful of what you are given. This is not equals to each other. Okay, guys, I trust that you guys can really appreciate what's going on here. In the sense that on one of the things, like for example here, you've got your Tn is actually equals to 2n, and then here your Tn equals to 2n plus 1, right? All right, guys, I know this was a long video. I trust you appreciate everything that happens today. Do stay blessed and enjoy the rest of your day.